Those were already.
They might have been. Yeah, they're supposed to sweep every night, but I don't know if that's the case.
Obviously not.
They sweep the aisles, not the desk though.
Yeah, who sees that? It's just like,
Right, who like walks by?
Yeah.
And they get paid, they don't should. Like, go out
Not that I want their job, but I also like, yeah. All right. So number 12, we're gonna FOIL here. So I FOILed, and this happens to be a conjugate. It's the exact same terms, just the opposite sign. So kind of knowing that going into it, that we know we'll get some canceling here. So we end up with 16, and then anytime I see I squared, I want to put a negative 1 in there. Oops.
Wait, how does 21 have no real zeros and all just imaginary?
21, we can talk about it.
Oh,
And so we get 80 there.
Yeah.
Yeah. No, it's okay. So 17. So 17, 18, and 19 are all really similar. Why don't we do 17 and 19, and then if you need 18 still, we can talk about it. But let's start with 17 and 19. So we have 2 plus I over 4I. Now there's a couple of things you can do here. When it's a single I in the denominator, you don't have to worry about the conjugate because I just want to get the I out of the denominator. So I can just multiply by I in this case. Now if you wanted to multiply by a negative 4I, that would work as well. But I know multiplying by I here is going to make that no longer an I on the bottom. So I'm just going to multiply the top and bottom by I. Now if you multiply by a negative 4I, that's okay. It should still work. It's just a lot more work at the end. So on top, I'm going to distribute here. So I have 2I plus I squared. And on the bottom, I have 4I squared. So on top, I have 2I plus a negative 1, so minus 1, right? Because I squared is negative 1. And then I have 4 times negative 1. So you can leave it this way if you wanted to. Now, technically, we don't leave a negative in the denominator, so we make that positive and change all the signs. Now, if you had this as your answer, that's perfectly fine. So yeah, if you had that. And then again, I just rewrote it so that the I was second. So these are all just other versions of that same thing. So don't let the negative in the denominator bother you too much, but if you were looking up your answer somewhere, they wouldn't leave it this way. They don't like that negative in the denominator. That's not a big deal, really. So let's look at 19 together, because 19 is definitely a tougher one. Like I said, 18 is kind of a mix between the two, but 19 is definitely tougher. This one's tougher because I can't just multiply by I, because I would still have an I in the denominator. This is where we have to use a conjugate. So anytime there's two terms, we have to use that conjugate, which is just the same exact thing, just the opposite sign of our I. But if I do that to the bottom, I have to do it to the top as well. The big thing with these, even if you have the concept down, you probably have a good chance of making like a silly mistake on them. So if that's like, there's so many places you can make mistakes. So we have the FOIL. So I FOILed up on top. And then I'm going to on the bottom as well. on the bottom, these 10 i's cancels what we want to happen. On the bottom. On the top, we have some things we can combine, and we're going to get rid of the I squareds. So I put in -1 for I squared on top, and we'll simplify that a little bit more. So on top, I have 15 minus 2, so that'll be 13. On the bottom, I have 25 plus 4, which will be 29. And then I can't divide those by anything. 29 is a prime number, so that's as simplified as that gets. So like I said, number 18 is just, like I think kind of an in-between version of those two. Oh, on 21, I think I have the real and imaginary zeros flipped. I'm sorry. We can look at 21 or 20 and 21. I think I have those flipped on them. They should be 3 real, no imaginary. That was your question, Cash. Did you hear that, bud?
Oh, 3 real, no imaginary.
Yeah, sorry. Let's talk about them though anyway. So on 20, and again, I'm just going to kind of sketch this. It's not going to be perfect, but and then 21, and 21 was my mistake, but all right. So we're not worried about highs or lows in this case. We're just worried about the zeros and where they cross the x-axis. So in this first one, and again, like I made the mistake on the second one, but number 20, they tell us degree of 5. That means there's 5 real or imaginary zeros. Now the real zeros, we see those on the x-axis. So 1, 2, 3. So there's 3 real zeros. So if there's up to 5, there's 5 zeros, that means there has to be 2 imaginary. And we can't see those on the graph because of the fact that you can't see imaginary numbers on a real graph. So we just consider that there's 2 because this has to add up to 5. Which is why I had this flipped here and it was like just those 2 inverted. But so this one is degree of 3. But we talked about this a very little bit, so it's possible you missed this. Was that it looks like there's only 2 zeros. Where's the third? You guys remember what I said about this? Yeah.
It's in the right circle.
Yeah.
It like bounces off.
Yeah, when it touches the axis and then changes direction right away, there's more going on than when it just crosses the line. So there happens to be, that's where we see multiplicity. Now, I would never have you try to do something with like multiplicity of 4. It's really hard to see on something like this. So probably stick to just 2, like 3 is tougher too. So this has multiplicity of 2 anytime it like bounces off the graph. So there's 1, 2, 3 real zeros, which means there's no imaginary, which is my mistake. So no imaginary zeros there. All right, so looks like 25 is next. Anytime it's x to the 4th or anything higher than x squared, I would always look to see is there a GCF first. There's no GCF. So in this case, we're going to see if we can factor this at all, because they don't give us any other information. So this x to the 4th again, is one of those that I feel like kind of looks like an x squared equation. So hopefully you guys are okay. We did this a few chapters ago in first semester as well. That x to the fourth is x squared times x squared. And I want to multiply to get a negative 36, but add to get a negative 5. So negative 9, positive 4. So that'll give me my negative 5. And if you are doubting this, you can check your FOIL here. This is the negative 9x squared, a positive 4x squared, which would give me a negative 5x squared. So this is going to give me each of my zeros. So you can solve it this way. You could factor the one on the left, but hopefully you're okay with solving and getting both zeros. So we move that 9 over, and we take the square root of it. So we end up with plus or minus 3, and that's a real solution. But over here, I do x squared plus 4 equals 0. I move that 4 over, so I get x squared equals negative 4. So when I go to take the square root, this is where my imaginary solutions come from. So that I needed those, so I have 4 answers. I found all the zeros. Happens to be that 2 of them are imaginary. I don't know a way to get that answer with, I mean, we can't use a quadratic formula or anything. Factoring is kind of the only way in this case. All right, then 31. You guys were okay on, what's the one that was really, 29 was tough. You guys were okay on that one? Ended up being okay. Because 29 is the one you do long division for, right? Yeah, but it went okay? Okay. All right, so 31, that's one I was anticipating having to do, was the long division. Oops. 31, so we have x equals 3, and 5 minus 2i are zeros. And they tell us that it's degree of 3. If it's degree of 3, we need 3 zeros, and they've only given us 2. Anytime there's an imaginary 0, remember that the conjugate also is a 0. So this automatically would tell me that 5 plus 2i is also a 0. And it's totally, I mean, you guys asked about this, and it's possible I made a silly mistake when I was foiling, unless you agree with what I have, but this is a matter of just being able to foil this through and write it out kind of nicely. And it's really easy to make little mistakes throughout. So I'm going to foil these two first, and then get this one involved. However, when I go to do this, remember it's always, it's x minus our 0. So it's going to be x minus 3, and then x minus 5 minus 2i, and x minus 5 plus 2i. So I have to distribute that minus n. And again, if you're able to skip a few of these steps, if you're good at kind of noticing what the factors should be now, feel free to kind of skip over if needed. But we're going to foil that. So I'm going to distribute here. So that's our first one, x times everything. And there are definitely patterns here, so if you start noticing the patterns, feel free to use those to your advantage. 5 times 2 is going to be 10i. So a bunch will cancel here. So the 10i should cancel. The 2i(x's) should cancel. X squared, and this is a negative 10x, 25, and then this is minus 4, minus 1, so bless you, plus 4, so 29. So I have this and this now I need to FOIL together. Oops, it's x minus 3. Alright, so somebody's like phone talking to us. What tall? 87. Oh, I made a mistake somewhere. No? Oh no, and I didn't. Never mind. I don't think. Unless someone caught something else that I've done wrong so far, but I'm getting the same answer again. So this is the minus 13x squared, and then this is a positive 59x. So that ends up being our polynomial. So degree of 3 is kind of just like a cop-out that we don't have to worry about any other zeros other than the ones that can be assumed based off our imaginary numbers. And if you guys have other questions on these, please don't hesitate to ask. Like if you feel like I already asked too many questions and so, you know, it'll be embarrassing or something, let me know. We can always talk about them. So there is an extra review.